Good morning. Welcome again for the final day of Reinforce. My name is Eric Weber. I'm a Senior Specialist Solutions Architect here at AWS. Today we're going to be going over automation in action, strategies for risk management. Alongside me I have...
Hello, I'm Steve Rice. I'm the General Manager of AWS App Config. Really happy to be here and talking to you. Great. We're going to start this morning with a little bit of an activity. I actually have a volunteer that I got to come up here before we started. I'm going to do a little activity that's going to show something about automation. Trust me on this one. All right, so I have a crisp $20 bill here, and he gets to take this home if he can catch this dollar bill between his fingers. So do you mind holding this out? Okay, so here we go. Ready? One. Okay, we'll try again. All right, try one more time. All right. Bummer. You get to keep it.
Thank you.
Thank you for volunteering. All right. Great. The reason I want to show that activity is to show the importance of automation, okay? I know we have some math and science people out here, so I'm going to talk about some math formulas here. But scientists have basically said that human beings can react in about 200 milliseconds. It takes about 200 milliseconds for some stimulus to hit your brain and allow you to do something about it. Okay, so there's a formula about motion and falling objects. Basically, distance equals half the force of gravity times time squared. All right, so I think we all remember 9.8 meters per second squared is the force of gravity. The 200 milliseconds is the time, so 0.2 squared, 0.04. All right, so that basically says that it's 0.39 meters. Trust me on this, which ends up being 19.5 centimeters. So an object in 200 milliseconds will fall 19.5 centimeters. A dollar bill is about 15 centimeters, and that's why your brain can't necessarily catch it unless you're really lucky, okay? Again, I bring this up to show you that you need to put some parts of your process together to allow you to react as fast as possible. So what are we going to talk about today? First, we're going to sort of set the table about the state of things and talk a little bit about automation. But we're going to break that down into three sections. We're going to have detective compliance, preventative compliance, and proactive compliance. We structured the talk that way. Hopefully this will all make sense. And then we'll end with some key takeaways. Okay, so really just going to start with saying, in the last year, we're seeing inside of AWS, and also we're hearing from our customers, that the landscape is changing tremendously. It's getting much wider. There's been huge developments, especially in generative AI that you've all heard about. There are now large language models that scan the dark web and that can help you get information and build tools if you're a bad actor. And bad actors are getting a bit of an advantage. Tooling is really improved. The cost of entry is much, much lower now. You don't have to be a sophisticated engineering shop to hack. There are a lot more script kiddies out there than there used to be. And then social engineering, I used to work at a social engineering preventative email security company, a cybersecurity company. And one of the tricks that was really easy to spot was when you got a phishing email and it wasn't written in a tone that seemed like it was the person writing it. It was pretty obvious this was not from the company's CFO, for example. But now with generative AI and ChatGPT and other technologies, it's really easy to craft an email that sounds very professional. I've actually gone into ChatGPT and into Bedrock and said, create an email from the CFO asking me to approve an invoice. And it will create a very compelling sounding email. So again, social engineering is just going to be leveling up. So I talked about math and science here. This is the math part about the math logical problem. So if you remember from your math classes, the logical postulates. So given three things, given that automation can react faster than a human, given that threat actors are using automation to get ahead, and assuming that you want to stay ahead of the threat actors, really, you need to make sure that you're adding this automation to your workloads, to your operational practices. I'm going to hand it over to Eric, and he's going to give us an overview of Cloud Foundation.
All right, thanks, Steve. So, given that we have to implement all of this, hopefully ideal automation to be able to start reacting faster to these security threats, to vulnerabilities, to non-compliance, I wanted to make a quick shout out to the Cloud Foundation white paper on AWS. Whether you are just getting started with AWS, you're familiar with AWS, or excelling at AWS, I'm certain that you'll be able to find something that is relevant for you so you can hopefully continue to improve your overall environment. For our discussion today, we are going to be focusing on the governance, risk management, and compliance related sections of the overall Cloud Foundation white paper. But before we actually kind of talk about the services, I do just want to, again, level set on what are the 3 different types of controls that we can implement within a given environment. So the first is going to be detective controls. So these are going to be reactive. These are going to be detecting based on configurations that are found within your environment. Now in this case, those configuration states, they can then be evaluated against a well-defined configuration state, and that is going to result in the resource either being compliant or non-compliant. The secondary control type is going to be preventative. Before it even happens, just prevent the action from being taken. So when we talk about these types of actions, again, these are going to be enforced at the action level, prevent the action from taking place in the first instance, so the resource can never be provisioned. And then the last one is going to be proactive. So when we start working within our infrastructure as code pipelines or CI/CD pipelines, we need to think about how can we be proactive so that the resource is never provisioned in a non-compliant state. So here we have our template that we are looking at to provision our resources. We have a well-defined configuration within there. It is then evaluated against our security policies to see if those resources that would be provisioned will actually be in a compliant state. Maybe an example in that type of scenario is I'm spinning up a new S3 bucket using CloudFormation. Now, if I define in my template that it's going to be a public bucket, but my security policies say that I should never have public buckets available, when I try to go and provision this, it should go ahead and block it, and it will not allow me to proceed. So what are the AWS services or functionalities that can help map to these different types of controls? So for the first one, for detective, these are going to be AWS config rules. We're going to be talking about that in just a second. The second one is going to be AWS organization service control policies, again, preventing the actions from the users to be able to take them, resulting in non-compliance. And then the third one is going to be CloudFormation hooks, which Steve will talk about later on. So now that we know our different types of controls, we can then think about how can we actually manage risk within our environment. So up here now we just have a typical Amazonian graph. There's no label or there's no values on the X or Y axis, but on the left side or on the Y axis we have the risk of change. On the X axis we have confidentiality. So now that we know, some of those different types of controls, we then need to think about our actual workloads that we are running. So whether these are workloads that you are migrating to AWS, you are building net new on AWS, or just trying out, these workloads do not carry the same level of impact. So you need to start classifying these workloads based on the risk of change as well as confidentiality that they carry. So in the upper right corner, we have these workloads that have a high risk of change as well as a high level of confidentiality. These workloads are typically going to be managed by a central IT department. They're going to have a higher level of controls applied against them, whereas maybe our lower level environments or sandbox test environments, those are going to have a lower level set of controls comparatively. So when you are when you're building towards implementing controls within your environment, you just need to keep in mind that we also need to identify which of those workloads or applications or business units carry the differing levels of risk as well as confidentiality. So to kind of put it into a more realistic example, let's imagine that we now have these different quadrants on that same graph, and where do you think a dev server would land? It's probably going to land in that bottom left-hand corner. So this is going to be a relatively low level risk of change and most likely a relatively low level of confidentiality. Whereas something like an internal wiki server may be in the bottom right-hand side. The risk of change is minimal. Wiki articles are intended to be changed. You have ways to roll back, revision, go back as needed if required. Whereas they also carry most likely a higher level of confidentiality. Now a CI/CD pipeline, high risk of change, that is your deployment mechanism to be able to spin up resources, make those configuration state changes, but outside of the source code itself, probably a lower level confidentiality risk. So what is a type of application that might be in the upper right-hand side? Well, most likely a payroll application. Everyone likes to get paid. If the payroll application is down, that is going to be a high risk for you. So any changes to that application carry a high risk level, as well as there is a lot of confidentiality that is stored within that application. So when we're doing this mental model of mapping these workloads based off of their risk of change or their confidentiality, this is just a way to kind of build towards what sort of controls do we need to apply against them. Our payroll application, that's going to have a high level set of controls. It's going to be very restrictive as far as what actions can be taken. Ideally, we would remove the human from the equation entirely and only interact with that workload using automation. Whereas our dev server, that might just have our standard or lowest level set of controls that we implement so that it enables the developers or application owners to be able to have flexibility to start innovating. So when we think about these controls, we see customers sometimes fall into the bad practice of trying to build out their controls for the lowest common denominator. And you should think of controls as an additive or layering aspect instead. So we do start with our standard set of controls that will apply to all of our environments, but we do just keep building on those for those workloads that carry either a higher risk of change or a higher level of confidentiality. We start layering on more controls on top of our baseline to restrict access to that environment to help reduce the overall risk. So talking about some examples, again, starting with that foundational layer, this is going to be example controls that apply to all AWS environments, whether it's dev, test, prod, QA, wherever the resource is, this may be our standard set of controls. So things like establishing standard IAM roles or SAML authentication, making sure that there's no static IAM credentials, lowering that risk of confidentiality. And then on the risk of change side, having clear ownership of who owns the AWS account. Internally at AWS, we're allowed to just go ahead and spin up new accounts. We have those permissions, but we do have to make sure that we are identifying who's the owner, who's the financial owner, who is going to take over, should anything go wrong with this account. Whereas if we then start talking about a medium risk environment, we may layer on some more controls at this point. Rather than just having a generic IAM role, we might start to build out some more fine-grained IAM policies that comply with least privilege. We might start collecting some additional application logs from our resources. As far as the risk of change goes, we might start looking to automate some tasks that are being performed, but still allow for a little bit of human flexibility. But again, building on the set of controls compared to our lowest level. And then for that highest level, this is where we're really trying to take the human out of the equation to reduce the potential risk of manual errors occurring. So in the case of confidentiality, this may mean that we have fully fine-grained security monitoring in place, completely automated as far as the risk of change goes. When we are deploying new resources into that environment or making configuration changes, they go through our infrastructure as code, standard pipelines, making sure that we have rollback plans enabled as well as high visibility for any changes that are occurring. So now that we've talked about those three different types of controls, we're now going to really dive into the detective side. So when we're talking about detective compliance on AWS, we're really going to be focusing on the service AWS Config. So AWS Config is a service that will collect the configuration state of your AWS resources, and you can also extend it beyond AWS to your on-prem or even hybrid environments. So AWS Config is going to record the configuration state of those resources, and then we can start evaluating their compliance against the defined state that we want those to be in. So talking about just some of the common use cases for config, again, it all starts with that foundation of recording the configuration state of resources over their entire life cycle. So as soon as I spin up a new EC2 instance, start recording that configuration state. If I then resize the instance to a different size, I attach new EBS volumes, ENIs, maybe change the IAM role that's attached to it. All of these configuration changes, config will record for you, and it can keep for up to 7 years. And once we have that configuration state recorded, we can enable config through rules to start evaluating the compliance state. Again, going back to what I was mentioning earlier as far as that S3 bucket never being allowed to be made public. We can have config monitor for that configuration change, and if that bucket flips to public, we can have the resource be marked as non-compliant. And then the last aspect is going to be visualizing these configuration changes over time. So aggregating this information across all of your accounts, all of your regions, being able to quickly evaluate your compliance state across your organization. For now, we're going to be really focusing on the compliance portion. We're going to talk a little bit more about rules that you can implement, as well as how you can automate remediation as well. But before we get that, just one more piece about config. AWS Config is a foundational service here at AWS. It is built on top of by many other AWS services, or that configuration state that I was mentioning is then collected and evaluated through these other AWS services like Security Hub, Trusted Advisor, Backup, Control Tower, Audit Manager. You can deploy these as conformance packs as well as firewall manager rules. So I talked about that configuration state and the compliance state. When you are working with config rules, you can also enable automatic remediation. So as soon as a resource is non-compliant, kick off a set of actions or workflow to attempt to bring that resource back into a compliant state. So AWS managed config rules have a variety of recommended remediation actions that are directly mapped one-to-one. There's over 100 AWS Systems Manager automation runbooks that you can use to bring those resources back into a compliant state. When you are configuring these rules or these remediation actions, you can either specify these to be manually initiated, in response to non-compliance, or automated. So as soon as that resource is identified as non-compliant by config, it'll kick off the action to bring it back in line. All right, so what does this actually look like when we're talking about a real-world environment? So up on the screen, we have an example architecture diagram, talking about how we can deploy out these config rules as well as some of these remediation actions. Now, we'll have some QR codes later on that will link to these different diagrams as well as some of those white papers, so you can always collect it at the end. But this is an example where we are deploying out these config rules as well as these remediation actions across our accounts and regions using what we call conformance packs. So the example here is really around restricting access to SSH. We never want to allow open port 22 to 0.0.0/0. So we deploy this out across our environment so that when those resources are marked or when those security groups are found to have an inbound rule allowing that unauthenticated access, it marks it as non-compliant, and we can use something like automation to be able to either remediate it, or in this example, kick off a change request for someone to go and evaluate should that rule actually exist. So why should we start automating this compliance as well as incident remediation? Tying back to what I was mentioning earlier as far as those high risk environments, we want to increase our overall security footprint. We want to increase our response time, reduce manual error that may be possible when humans are interacting with the environment. We want to make sure that we are meeting our compliance standards, whether those are our internal security policies and compliance policies, or that we're being held to federal regulation as well. And then, of course, it helps us just respond faster. Going back to what Steve was mentioning at the beginning, we need to put in place automation so we're able to react fast enough. So how can we get started with building out these remediation actions? Last year at reInvent, Systems Manager launched the Automation Runbook Builder, which we'll take a look at when we go into a demo in just a moment. But this is now a new visual builder that's available within the Systems Manager console that you can use to start building out some workflows that can bring these resources back into a compliant state. So the standard type of benefits around this, just reducing the level of complexity as far as getting started with building out these runbooks. It's more of an intuitive visual drag and drop. It also has some integrations with Amazon Q Developer to highlight any code securities, vulnerabilities that are identified and helping you resolve those, as well as just syntax-related highlighting. So let's go ahead now and flip over into the console and take a look. Okay. So I am logged into the Systems Manager console. What we're going to do, just as a quick demo, we're going to walk through that runbook builder. In this case, the example runbook that we're going to build is around maintaining a compliance state for an application load balancer. And we'll actually take a look at that first. So over in the EC2 console, So in my environment, I just have a simple application load balancer deployed. And then in here, I have a listener that is configured for HTTPS or 443. Now for this particular listener, I have a security policy in place here that is just defined, what type of cryptography is going to be used as part of the listening process. So let's imagine that I have a security policy defined that specifies I should have a different a different policy applied to my security listener. Now in this case, there is the AWS recommended TLS 13-1-2 2021-06. So in this case, my resource is in a non-compliant state and I need to remediate it. So rather than performing this manually, we're going to take a look at how automation can take care of that for us. So over in the Systems Manager console, I can go and start creating a new automation runbook. Maybe I'll zoom out a little bit here. Now I do have my brief instructions on the right-hand side. So first, just going to add a name to the runbook itself. Fill out some basic information so that users that are leveraging or initiating this runbook know what is going to be performed. So in here, I am adding just a couple attributes that will then be passed in when I kick off the runbook itself. Working with automation, we can specify for it to take actions on our behalf. So in this case, we have to provide some IAM roles, as well as what is the ARN of the load balancer itself in question. Oops. Now, the second parameter that I'm going to add here is just what is that security policy that I specifically want to allow. So here I can say that this is going to be the only type of security policy that is allowed and it's going to be enforced against that resource. And then we can actually start including some actions. So as a first step, I'm going to just evaluate what is the current state of that application load balancer using the action assert AWS resource property. So in this case, it's just going to ensure that the load balancer and the listener is using the policy that is defined in that overall document parameter. So here I can specify that I want to make a ELB v2 call. I'm going to specifically make the describe listeners API call. And then in this case, I'm just going to extract some of the information that is provided in the resulting output. So here I'm saying that I want to ensure that the value that's returned in the output matches that security policy that I defined in the beginning. And then I also just need to include passing in the load balancer ARN, and this will provide it from the overall document parameter. One final step that I'm just going to add for this is just to say that if the resulting value does not match my security policy, then we need to go ahead and continue on to our next step. So using automation runbooks, we can make calls just using the AWS API. We can also include Python code or even PowerShell code as well. Start performing some branching actions based on the results of preceding steps. So here we'll add another action just to pull that information out for us. And we're going to extract some information from that resulting output so we can provide it to our subsequent steps. So in this case, we are just pulling out the ARN of the listener for that load balancer. So now that we know that we need to update our policy, we can then add another action just for modify listener. In this case, it is then going to make that action to revert the listener to the appropriate policy instead. In here, we're just saying that we're going to pull in the output of the preceding step and just pop it in so we don't have to continually input new information. We can pass the details between the subsequent steps. And if we go to the outputs, then we're just going to pull out the ARN of the listener so that we can then use it in our final step. So we now have our runbook that's going to just evaluate the current state. If it is then not matching our compliance state, go ahead and make the change to update it. And we're going to add one final step to ensure that our resource is compliant at the end. So essentially trust but verify. So here we are then just going to say, again, we want to make that describe listeners call. If we then say that we still want to make sure that the resource matches our security policy, we can input it here. And at this point, if everything works, or if everything's correct, we should be good to go. So let's give it a try now. So I'm going to go back to my application or load balancer and copy the ARN. And if I go over here to execute this, I can then provide just a few values, provide in the ARN of the load balancer. I could pass in a service role to perform the action on my behalf, and then I have my security policy that I want to enforce on that resource. All right. So I just initiated the runbook, so it's going to start making those API calls against that load balancer, confirming the current state of the security policy, and then looks like I might have messed one portion up. But if we take a look here on the first step, we can see that the property value of that RES security policy does not match the desired value of that TLS 13/2021-06. So because of that, my runbook then proceeded with the subsequent steps to go ahead and modify the listener. And it looks like I might have missed a portion on my final step around confirming the state. But if we go back to our load balancer here and we open up that policy again, or the listener itself, we can see that our automation runbook successfully changed the security policy from that RES1 to this 2021. Now, again, what was the intent to really show here is highlighting these automation runbooks that you can either use out of the box. If I go back to the documents section, for those AWS config rules, like I was mentioning, there is a wide variety of runbooks that are available that directly map to config rules that are managed by AWS. So one of the examples probably here is going to be around that S3 public access blocking or S3 access configuring the bucket itself. So when you're working with config and these rules that are managed by AWS, we have these direct mappings for automation to bring the resource back into a compliant state. So let's take a look at that portion now. So over in AWS config, I already have it enabled within my account, meaning that I'm recording that configuration state of my resources. And let's imagine a scenario where in my environment, for this particular account, this particular workload, EC2 instances should never have a public IP address. So in here, we already have a managed rule available for it. In this case, I can just go ahead and specify that I want to enable a new rule for no instances should have a public IP. Now, for these config rules, there's a few different portions to call out here. The main one is going to be these trigger types. So config rules have two different types of methods as far as when they are initiated, to start monitoring or evaluating the configuration state or compliance state. And that can either be as a result of changes to the configuration or the resource itself, or you could also specify for these to be periodic. Now, when you're working with AWS managed rules, they'll come with some defaults, but if you need to customize them, you can. The first one is just going to be, again, in that case of that EC2 instance, when I spin it up and it has a public IP, there's now a configuration change that has been performed. Alternatively, I could also run these periodic. Some of the rules, again, just depends on the scenario, which one you'll want to use. But in this case, we'll just say that we're going to enable this for our EC2 instances, and I can hit save. Now, at this point, config is going to now evaluate my EC2 instances that I have spun up within this account and start determining if they are compliant with that rule, meaning they do not have a public IP. So without having to wait, probably a minute or two, we'll flip over into one of the other regions where I have an EC2 instance already spun up. So in this case, I have this EC2 instance, it's pre-provisioned, it has that public IP address, and if we go back over to config, and I zoom in a little bit, we can see that resource is marked as non-compliant because it has a public IP address. Now at this point, config is not taking any action on my behalf. So if let me just remove this real quick. If I want to say, when a resource is marked as non-compliant, it has a public IP address. Depending on the environment, that'll help me define what type of action I should take. So if this is maybe a dev environment or a sandbox environment, I might not actually take any actions against it. But if it is a production environment where there is that high level of risk, I may want to just go ahead and stop the EC2 instance, or I could even terminate it. Again, depending on the appropriate action, it might vary within your environment. But for these config rules, I can add that remediation action that I was talking about earlier, whether it is either a manually initiated remediation or automatic. As soon as the resource is marked as non-compliant, kick this off. So in this case, I can select that runbook provided by automation to stop the EC2 instance when it is non-compliant. I can specify for config to pass in a value, in this case the instance ID, to that automation runbook, so I don't have to worry about providing the parameter myself. And then I do just have to specify an IAM role for the service to take actions on my behalf. So if I save this, my config rule now has a remediation action associated with it. If I were to spin up a new EC2 instance, it'll mark it as non-compliant. I could reevaluate, but I'll just go ahead and kick it off manually in this case. So I selected my non-compliant node, I hit remediate. Now the action has been queued over in automation. If we take a look there, so the stop instance runbook has been initiated as a result. It's going to start changing the instance's state to stopped. If I go over to the EC2 console and zoom out and refresh, my instance is now in a stop state. So using these config rules and these remediation actions, we can implement some detective compliance as well as automate the process of bringing that resource either back into a compliant state, when it is just a configuration state change, or I could be a little bit more restrictive about it and fully terminate the resource and clean it up should the resource be in a non-compliant state. All right, so with that, we can skip through. We had a couple backups just in case. And now I'll go ahead and hand it off to Steve, and he's going to talk about proactive compliance.
All right. Don't need these headphones on. Great. Thank you, Eric. So we're going to talk about proactive compliance. Again, the best kind of remediations are ones that are implemented before anything bad ever happens. This should really be part of your shifting left strategy. You probably heard that term before, but essentially shifting left means moving security upstream during the SDLC lifecycle. And this is what we want to do. You want to put your compliance and your remediation upstream as early as possible in how you are operating your software. So the first tool I'm going to talk about is CloudFormation Guard. If you didn't know, CloudFormation is infrastructure as code solution. And a lot of our customers will use it to deploy resources to production, of course, in an automated fashion. But very quickly, the CloudFormation scripts and stacks can get out of date as engineers are making changes to them. Something that at one point when it was scanned was okay, no longer is okay. So CloudFormation Guard allows you to put rules into CloudFormation so that you can make sure that there's no drift and there's no entropy from your security point of view as you're using CloudFormation. And again, it lets you sort of have the security by default shifting left strategy within your infrastructure as code setup. I'm going to show you a couple examples of this. So the first one here is that you might want to make sure that all of your ports in EC2 are not using the default ports, kind of a common one that we see. So this is like a rule you put in there that says, I want to make sure we're not using a default port. Another example here is that you want to make sure that everything's encrypted. Again, when the CloudFormation script is put together first, you may have this checked, but you really want to make sure it's constantly checked every single time you're deploying your stack. So this is a way in EC2 to make sure that encrypted is not equal to false. Pretty simple. A third example is that if you're using tag-based auth, you will want to make sure that the tags are applied correctly and the tags are indeed approved tags. And so this is an example where we may have something called tag list, tag underscore list. You have a list of tags that you have approved to provision resources, and this will just ensure that those tags get used. So a lot of these are sort of like checks that say, you know, they're almost like syntactic checks to make sure that your CloudFormation is set up correctly. There's another kind of check that you can do that we sort of think as a logical check or a functional check or a semantic check. So we have the syntactic and now we have the semantic check. This really looks at functionality. So for example, you might want to say, oh, I want to make sure that my database is not publicly accessible. So you can check your settings and your configuration for that. But you also might want to double check and say, well, I'm going to try to access it publicly. I want to have a function out there that will go and try to access it publicly just to make sure that it is not publicly accessible. So CloudFormation hooks allow you to do the same thing, add that functionality in there, those functional checks. So in this diagram, I'm going to have an example where I'm actually going to use config. Eric talked about using config. So you create a stack in CloudFormation. Now you have a hook out there as you create it that says, let me just double check that this complies with config. So it's kind of a functional deep check into config. And the first one, it comes back non-compliant, and you'll receive an error message, and the stack is never deployed. The second section of that flow here is the opposite of that. You create a stack. CloudFormation double checks on config. Config says, yes, this is OK. It comes back compliant, and then you provision the resource. So again, those are two sort of proactive checks that you can do. They're not mutually exclusive. You can do the syntactic check or just the, is it configured correctly? And then you can do the functional check with CloudFormation hooks. I'm going to talk about another tool that you should think about having in your toolbox. I'm going to do a demo on this a little later. AWS Systems Manager Incident Manager is a great tool for managing incidents, the full life cycle of incidents. What's probably worth calling out about Incident Manager is it's based on how we at AWS manage incidents as well. So it sort of has all of those best practices that we consider important inside of AWS, and we've turned them into features into Incident Manager. And so really, Incident Manager allows you to set up on-call rotations, you can set up response plans, you can set up escalation plans, you can do post-incident analysis. We talk a lot about, in our well-architected framework, we talk about the correction of errors process, COE process. That's just a blameless autopsy that we do to make sure that that same thing never happens again, that we're somewhat religious about doing that. And so Incident Manager allows a workflow during an incident and then after an incident for you to do all that. And of course, all this can be automated, and I'll show you a little automation in there. Another tool that I'm going to recommend, I'm wearing the shirt, and I'm the general manager of AWS App Config, which is part of Systems Manager. App Config is usually thought of as something like a feature flagging solution. So you can use feature flags to release features. But really, you can have security flags in there as well and some operational flags that you might want to think about. The reason why this is important, what you have is you have little bits of configuration that change your software's behavior on production. And doing a configuration change is usually a lot faster than pushing out code through your CI/CD pipeline. So if something's suspicious out there or something's wrong out there, you want to be able to react very quickly. We'll talk about that, less than 200 milliseconds. You want to react very quickly to be able to address that. And again, if you're having to push code out to address the issue, that may be too late at that point. If you're on an application security team or a SecOps team, you're really going to want to talk to your application team and tell them, hey, I want you to build in these dials and switches that allow me to do things on production if there is a security incident. So some of those examples Of course, you probably have IP-based blocking. That's something that's really common. But you might want to have account-level blocking. And that's not something you can do at the IP address, obviously. That's something that you're going to want to have a block list so that, again, you see suspicious activity, you might want to block a particular user ID. And you can do that if you manage a block list or maybe an allow list. You can very quickly make the change and push it out and block that malicious user. There might be times where you actually are in a scarier situation. You want to shut off some non-essential subsystems. And again, feature flags or security flags allow you to quickly turn off something that should be turned off. So again, that's a dial or a switch that lets you do that. And then the third one is something we hear from customers. I really like this one. It allows you to set the logging verbosity from info to debug. So if you think that something is interesting going on, but you're not quite sure, an alarm goes off, you can automatically have your debug logging verbosity set to a much higher level so you have a lot more information in there. I actually do have a demo of that. Let's see here. Great, okay. So what I have here is a CloudWatch monitor. I'm going to sort of daisy chain 3 things together using automation. This is just a sample monitor, but for example, let's say this was a monitor that's looking at a particular API. It might be something like an IAM API that says list roles. And you have a standard deviation that says normally list roles gets called this frequently on these days at this time. But I want to be alerted anytime that we go outside of that. So we have in CloudWatch anomaly alarms. So I want an alarm that says, looks like something is calling list roles way more frequently than normal. So today this is an alarm that's just configured, and my pager would go off if this alarm triggered. I'm going to go ahead and add some automation. So this is the screen that defines the alarm. I'm not actually going to change anything on this screen because I'm not going to change the definition. I'm going to change an action here. So if this alarm goes off, not only do I want my pager to go off and a message to be sent, but I actually want to have some automation kick in. You can do things like set up a Lambda action or a ticket action, but if you look at the bottom here, there's a systems manager action. So I'm going to add a systems manager action here. And I was telling you about incident manager. In this case, I'm going to create an incident if this alarm goes off. I'm going to automatically kick off an incident process. Now I can also set a particular response plan. I've actually already defined these response plans. These are things I've defined inside of Incident Manager. So because I'm saying this is like suspicious activity, I'm going to click on the response plan of I automatically want to kick off suspicious activity response plan. Okay, I'm not going to change anything there, and I'm going to update the action. Okay, so now what's going to happen is this will be bouncing around, and again, if the threshold is breached, it's going to automatically create an incident in Incident Manager. I'm going to hop over to Incident Manager for a second. So again, what I've done is I've connected through automation CloudWatch to Incident Manager. This is Incident Manager. I'm going to look at that response plan I just attached. So this response plan has some details. It has some defaults around messaging. So when an incident starts, it's going to show this messaging. It can do certain engagements. You can set up contacts when the response plan is in effect. You can also have an escalation plan that allows you to page somebody, and if that isn't responded to, it'll start escalating up. So I have an escalation plan here. I consider it a Sev2 incident. I've predefined that. But then you can set up a runbook. Eric just showed you the visual runbooks. This is where the other automation comes in. We have some third-party integrations too, but I'm going to go in and I'm going to edit this response plan. So not only does it have this definition, and you can set up chat and some engagements if you like, but I'm going to have a runbook run. I'm going to select a runbook that I've already pre-configured. And this is the logging verbosity runbook. What this is going to do is when this response plan is enacted, it's going to toggle the verbosity from info to debug. Okay, I need to specify what version of the runbook. I'm going to choose latest at the time of execution. I know the latest is always going to be right. And I need to define a service role. I already did that here. Okay, I'm going to update the response plan. Oh. Sorry, hang on one second. Okay. So now this response plan's been updated. Let me jump over, and I've sort of connected the three things here: CloudWatch, Incident Manager, and I've connected that to AppConfig, which has some flags here. These flags are security flags. I called them logging verbosity flags, and I have two of them inside of AppConfig. One is the log level. You can see it's set to info. And the other is a log destination. I'm not going to change the log destination, but there's many different things that you can configure, and you might want to configure on the fly during an incident. Okay? So let me jump back to Incident Manager. And because the threshold has been breached, I have an incident that's in flight. It's less than 1 minute, but it says that there's an IAM anomaly detected. I'll take a look at this incident. And again, Incident Manager will be able to show us a summary of the incident. Some data there that's interesting. It also does timelines, so it does this automatically for you. You can add in notes as you wish. So checking in. And it is sort of that full life cycle of an incident. Okay. Let me go back to AppConfig, and you can see AppConfig is indeed set to debug here. So now I'm getting a lot more information during this incident about what's going on. Flip back to Incident Manager here, and I'm going to go ahead and just resolve this incident since it's a demo incident. I'm going to say this can be canceled. And then I get a prompt to create this analysis. And I'm not going to do this right now, but this allows you to do that correction of errors thing, which is so, so important. The ability to do a deep analysis right after the incident as quickly as possible and put in remediations in there so that exact thing doesn't happen again is a core principle of ours. So, great. All right, how are we doing on time? Okay, I think we're doing well. So, at Amazon, we talk about something called a flywheel quite a bit. And a flywheel is really a series of processes or mechanisms that you put in place to start to go faster and faster. It accelerates your response time. It accelerates your business. And so you should really think about building those proactive compliance pieces, the detective, and the reactive. And at first, you might put in some of these things manually. And you might execute these runbooks in a manual fashion. And then you start to add automation in there, and that starts to build on the proactive, detective, and reactive compliance pieces. And you can see the flywheel starts to spin faster and faster and really builds that wall of security around your organization. So again, thinking about automation as that flywheel will really accelerate your ability to protect your customers and your company. All right, Eric, do you mind coming up here? We have a couple key takeaways. You want to do the first one? First couple.
All right, great. So just to sort of wrap everything up, at the beginning we talked about some of those different types of controls, through the detective, proactive, and preventative. We can leverage AWS config as well as Systems Manager automation to enable that detective compliance. As soon as that resources makes that configuration change that would result in non-compliance, we can implement automation runbooks to be able to revert the resource back into that compliant state. We can then start shifting left to proactive compliance using CloudFormation Guard to prevent the resource from being provisioned in a non-compliant state in the first place.
Yeah, and I'll take the last two. So use Incident Manager. It's that full life cycle for incidents and allows you to collaborate and automate your response plans. And the last bullet point, really automation is just so critical to staying ahead of the bad actors. There's an expression that every minute counts. And what I'd really say, it's not even every second counts, every microsecond counts in today's world, that you really need to be able to reply instantly. And the best tool you have is that automation.
Yeah, so then we have a couple different QR codes. If you're looking to get started, the first one is going to be around those automation runbooks that I was demonstrating. Second one is going to be a link to our GitHub for CloudFormation Guard. There's a lot of different example controls that you can put in place using Guard. And then the last one's going to be for our Architecture Center, giving a better insight into how you can refit your environment, to start implementing some of these different level of controls.
Thanks very much.
All right, thank you, everyone.